G'day chemistry students, in this video we are looking at 7.5.6. The main aim of this lesson is to bring together a lot of what we've learned about with our organic chemical reactions. We can take all these reactions and begin to construct flowcharts which show the progression of organic chemicals from one species to another. Let's get into it. Now this is an example of what a reaction flowchart can end up looking like. Keep in mind that this flowchart has additional reactions that we have not learnt about in class, but includes a large variety of reactions that you have already seen before. So for example, we know that alcohols are able to form aldehydes, or at least primary alcohols are in particular, through an oxidation process. We know that aldehydes can then further oxidize to form carboxylic acids. Now this flowchart is able to outline the reactions, essentially what we start with, the direction that it goes in to show what we end with, and then also includes other reagents as well as other reaction conditions and or catalysts. Now within the scope of this course, we can do activities which have us interpret flowcharts. However, I wouldn't say that this is the main aim of the course. Within the scope of the syllabus, the expectation is that you are going to be required to be able to construct or complete flowcharts rather than be able to read and interpret flowcharts and then use the information that is on there. What that means is when constructing or completing a flowchart, you will need to have a really in-depth understanding of all of the chemical reactions that we've learnt about within the scope of this course. What the reactants are, what the products are, what the reaction conditions are, as well as any potential catalysts. So this is a question that was shown in the 2021 HSC exam. Essentially, what we need to be doing is completing the flowchart which has been given to us. We have been shown our initial reactant, our starting organic chemical. We've also been told what one of the end reactions will end up producing as well. With this information alone, as well as the reaction conditions going from our starting reactant to A and B, as well as our reaction from A to C and B to D, and D to our final product, we should be able to figure out what our compounds are. Now I'm going to do a quick solution for you in this one just to show you some of the problem solving processes that we can take, and hopefully what we should be able to appreciate by the end is that there is a lot of information that we need to be using and applying from all of the lessons that we've had on organic chemical reactions. So first off, in this reaction here, we've been told that we are doing a hydration reaction. Now, hydration is another word for addition of water to what we have here, a double bond and alkene. So when adding water to an alkene, we should expect two products. When the water comes along, we're expecting the addition of a hydroxyl group and a hydrogen, but we don't know where the hydroxyl group is necessarily going to go. It could add to either carbon that is a part of the double bond. So we should end up with two products. We should have one where the hydroxyl group has been added to the carbon that is on the end, the terminal carbon, as well as a product where the hydroxyl group has been added to the carbon that is in the middle, essentially making a secondary alcohol. Now, both products are possible, and currently we don't have enough information to determine which one is A and which one is B. For the reaction between A and C, we see that we have a substitution reaction with hydrochloric acid and zinc chloride. So what we're expecting to see is that the hydroxyl group comes off and a chlorine comes on. Now, this could happen for both a primary or a secondary alcohol. So we haven't been given enough information yet to know what A or C are. If we look at B though, what we see is that B produces D through an oxidation reaction with acidified potassium permanganate. Now we know that oxidation reactions can happen for primary and secondary alcohols. However, they end up producing completely different products. For a primary alcohol, it will produce an aldehyde first, followed by a carboxylic acid if further reaction is allowed. For a secondary alcohol, we know that if it's oxidized, it will end up producing a ketone. So when we look at reaction D here and its final product, we see that D undergoes reflux with methanol and concentrated sulfuric acid and forms an ester. This group here is an ester. And we know in our esterification reaction, we react an alcohol and a carboxylic acid. So we know that D must be a carboxylic acid. And if D is a carboxylic acid, then the only way that it could exist is if B was a primary alcohol. So if B is a primary alcohol, it forms into an aldehyde. That aldehyde further oxidizes to form a carboxylic acid. So we've been able to identify essentially what B is. And if B is a primary alcohol, then A must be a secondary alcohol. From here, we can then predict all of our products. So if A is a secondary alcohol, we can draw that in. We can also do our substitution reaction as well. So we're replacing our hydroxide for a chlorine. For B, we can draw our primary alcohol. Apologies, I just noticed that there should be an extra hydrogen here, so I'll put that into for our primary alcohol. And we know that if we oxidize this primary alcohol, that we're going to end up forming a carboxylic acid as a product as well. So I can draw that in. So by looking at the solution for this HSC question, what I'm hoping you can see is the only way that I was able to get anywhere close to finding a solution for this question was understanding all of my organic reactions inside and out, off by heart, knowing what the reactants and products were, knowing what those reaction conditions were, and furthermore, having an understanding of when there might be multiple products and what they might be, as well as understanding how reactions can differ for primary, secondary, and tertiary alcohols. All of that information was absolutely vital because they provided the rules to be able to solve what is essentially a puzzle. And that's kind of how all of these flowcharts sort of work within the scope of the HSC. You're given a puzzle to complete, and this puzzle is essentially solved by understanding all of our organic reactions rules. If you don't understand those rules or you can't recall them off the top of your head, you're going to find it really difficult to be able to complete the puzzle effectively and accurately. Thank you very much, everyone. In the next video, we're going to be capping off our unit with just a couple of lessons on polymers. These are the fundamentals that make all sorts of fabrics and plastics. There are two main kinds of polymers: addition polymers and condensation polymers. So in the video to come, we'll be focusing on what they are, how they're formed, and the chemistry behind them. But until then, have a good one.